So today we'll be looking at this question given right here. This question is about why do the boiling point and the freezing point increase on adding a non-volatile solute to a liquid. So to answer a question, we'll be taking a use of change in or entropy. Okay. So let us consider the entropy of vapor to be here, and let us consider the entropy of uh, solution to be here and solvent to be here, pure solvent. So this is change in entropy. Okay, so first let me explain why do we place the entropy of solution below the above the entropy of a pure solvent. This is because that for an ideal solution the entropy of mixing is always positive, so therefore the entropy of a solution is always more than that of the solvent. Okay, so if we convert the solution to the vapor, first let us convert solvent to the vapor. So this is the change in entropy of the solvent, and now when the solution is converted, this is a change in entropy of the solution. So this graph implies that delta S of the solvent is more than delta S the solution. So we know that this is a phase change. So for a phase change, we know that entropy of vaporization is equal to enthalpy of vaporization on the temperature, and for this case this is the boiling point. So this is the equation, and now as we know that the entropy of the solution or the solvent, the entropy of the solvent is less than that of the solution. So this we can know. For now I'm talking about enthalpy of vaporization. So we know that since this is an ideal mixture, the enthalpy of mixing is 0. Therefore the enthalpy of solution and the solvent will be the same. So if we know, so this is the solution as well as solvent, and this is vapor, delta H. This is same. So this quantity is always constant. Now if we manipulate the equation a bit, we can get the equation as enthalpy of vaporization upon entropy of vaporization. This is the main relation that we'll have to remember. Okay, so for every point this is same, and if we consider the solvent, we know that for solvent this quantity is higher. So this basically suggests that boiling point is inversely proportional to 1 upon change in entropy, and we know that for the solution this is lower than that of the solvent. So for solution temperature is higher than that of solvent. So now we'll be looking at freezing. So we can explain freezing the same way we explain boiling. So let us consider the entropy of solution to be here, entropy of solvent to be here, the entropy of the solid will be here, because entropy of the solid substance are less than that of the liquid. Okay, this is delta S. Now we can see that change in entropy is more than that of more than for is more for solid. Okay, sorry, solution. Here will be solution and here will be solvent. Okay, change in entropy will be more for solution. Okay, so now if we write the same equation, as we know that this is the phase change, we can write entropy of vaporization is equal to delta H vaporization upon freezing point. So if we manipulate the equation a bit, not vaporization, here will be having here freezing, or here there is fusion. So we can see that the entropy change for solution is more than that of the solvent. So we know that this is constant as we have explained above. So this then gives the relation that the freezing point is inversely proportional to entropy of freezing, which again gives rise to the equation. Oh, sorry. So again gives rise to the equation that freezing of solvent is less than that of the freezing point of solution. Hence the freezing point drops and the boiling point increases. I hope you understand my explanation. Thank you.